My name is Jim Burnham. Many of you know I'm a mechatronics teacher at Silicon Valley CT, which is a public high school here in San Jose. And I thought, oh, I'm going to go figure out this challenge, and I'm going to do the tabletop challenge because honestly, we hadn't actually done it in my class last year. We played with some robots. They got some things going, and they were playing with them on the ground and stuff like that. But we hadn't done a tabletop challenge, and so this summer, I thought, how hard can it be? and so I actually got a paid gig to do a summer workshop with some students at Del Mar High School, and so I went and put together kind of homebrewed 12 of these little robots. And I bought the plate, and then I bought all the motors, and I 3D printed a bunch of little mounts for it, for the battery and the motors and stuff like that, and then I cut this top piece out and put it on there, set it all up, and I realized, obviously, that these are fairly cheap little motors, and they're not matched to each other at all. And so here I am in the middle of my workshop, and the old adage of, I don't usually test my code, but when I do, it's in production. Yeah. So I've got students that are working on this, and I had some template code that had, move forward, go backwards, spin right, spin left, and all that kind of stuff. And I realized today in class that you have to compensate for all that kind of stuff. And so I guess I'd like to get maybe a little bit of feedback on, like, with these cheap motors, and I think my next project is to get a little bit better motors for my next time I put this together. But here are my thoughts, right? A couple things happen when you turn these on and start driving them forward. One, since the motors aren't matched exactly, they'll tend to turn right a little bit or turn left. And so I thought, okay, great. That's probably fairly easy to fix if you put like a driving forward error correction and a driving backwards error correction for the left motor and the right motor, and then you just put that in a kind of a user template or something. And so then every time you tell the motor to go forward, you add or subtract, some error correction for it, and then for each car, though, is completely different, so each car has its own profile. The other thing that I found was that when you tell it to stop, the freewheeling of each motor is different, and so then it tends to kind of coast and turn a little bit. And I haven't quite figured that one out, other than coming up with another, stopping, braking, error correction, so that when you tell the motors to stop, you tell one motor to maybe stop a little earlier than the other one, and fiddle with that kind of stuff. I don't know. That's my thought process.
I could throw out that all of what you're saying is harder than what you think.
Yeah, no, I'm sure.
I'm saying you can't just put a simple correction factor because it's nonlinear.
No, I understand. No, I totally understand that there's so much nonlinearity here. I'm just trying to figure out, what to do. And then I guess what was the third thing? Oh, yeah, here's the other thing, right? So I thought the other day, I was like, oh, how hard can the tabletop be? And I had the little sensor and sticking out here, and it's driving on, and they work really well, except when I tell the motor to stop, it does, about here, right? And so that one was, my attempted solution to that is you actually tell it to brake. So that when you tell it to stop, you actually tell it to brake for,
That's what happens when it goes off the table.
Yeah, exactly. That's what happens when it goes off the table. It breaks. No, but to put a braking routine in so that when you're telling it to stop, it actually stops. You're putting it in reverse to do it. So anyway, that's my experience with these, and I'm like, holy crap! I have to come up with some better ways to actually manage this. So
yeah, expensive motors will have the same fundamental problem, maybe not extreme. You need encoders so you know exactly what they're really doing, or you define your solution to where it's correcting. So if you're looking for the ball, you just always steer towards the ball or the cube,
right?
And it doesn't, and that will correct. You're always, if it's veering the wrong way, well, you're just veering harder.
Yeah.
One thing you might try for the stopping problem, it means messing with the electronics a little bit. But if you want to stop, have a switch not a manual switch, but electric switch, if you will, that will disconnect the motor from the voltage source, short right across it.
Okay.
Now, that gives you as much dynamic braking as the motor's going to get. And it'll stop pretty quick. You do that across both of them, they should stop at a pretty short distance.
Yeah, well, I mean, I found that if I tell it to go in reverse for, 2 microseconds, it stops.
It should be, if it's a standard motor driver, if you raise forward and reverse at the same time, that shorts out the motor.
Oh, yeah, no, I know.
I mean, that's the way to stop.
Yeah.
And if you've got a cheap motor controller, if you break the motors quickly, all that energy that's stored in the coil gets
dumped. Yeah. No, and I've got to add some capacitors and other stuff onto this system to do that kind of stuff.
I always use servos.
Yeah, no, and that I actually have another setup that I'm going to set up with some servos and stuff, and then that's like easy.
I'm getting Futaba 3003 knockoffs for like $5.
Yeah.
From China.
Yeah.
Now, they need to be. They're only 180 degrees, so they would have to be modified.
Yeah.
And continuous rotation servos, relative to those are expensive, but the time save. Yeah, because
yeah.
you got the electronics, the gearbox, and the motor.
Yeah, well, and part of my whole project here is that, in my class, I'm going to spend time, we're going to learn about motors, and it's going to be off the car, and they're going to be just playing with motors and motor controllers. They're going to learn all that stuff as they put this whole thing together. And so, those are kind of my projects. There was one more thing that I was like...
Constant voltage to the motors. It's, if you have a push-pull power supply, then as the battery gets lower, you still have the same voltage driving the motors so that they're more consistent.
Okay.
And on the sensor issue with finding the edge, what I did was I put the sensor on the end of a stick.
Yeah, far, a little further out. Yeah, no, I get that. I've got some little 3D printed little things that'll stick out a little bit that way too.
Yeah. The other thing with most brushed DC motors tend to run differently forward and reverse speeds because of the preferred hysteresis in the motor.
No, and so when I was going to be coming up with the the car profile, there was definitely going to be a going forward profile and a going backwards profile and all the error correction that I was going to try and do for both directions.
But even if you solve that with driving it with a PID controller, which is a little sophisticated for that, wheel slip. And on a small computer, one wheel is going to start before the other wheel is going to start, and your pose is going to be off.
Yeah.
So one way to solve that is to use a tricycle, use a servo to steer, and just use 2 wheels to go forward.
Yeah.
I give lectures on robots, and the thing that I tell people is sensors lie all the time. They won't lie consistently all the time. You need to, so when you have an inexpensive robot, you care less about the errors. You make small corrections. The more you have invested in the robot, the more you start caring about the truth about what's going on.
Yeah.
And you end up having, so you have to have ultimately a feedback system. It has to be a closed loop system.
Yeah.
On it, and then you need to start fusing data statistically to try to glean some semblance of truth.
Yeah. Well, I'm running this with Arduino, so
Even Arduino, they do a lot. They're not stupid.
So.
Yeah, just another thing on one thing I noticed was the surface has to be hard as possible. If you try running across the carpet, you get a bunch of error correction codes, and it would be totally different. Yeah,
and these wouldn't be very good on carpets because I've actually got a little post on the back, not a wheel even. So it needs to be a hard surface for it to drag around on. Yeah, Chris, you had one?
Yeah, I just wanted to say these are all problems that people come in with these cheap motors, the mismatching, the surfaces. And I actually, in my presentation, I'm going to give a great demo which will solve all of your problems.
Whoa! Whoa!
And if you act today.
All right. Well, so I just, so my goal is that because I'm starting school in 2 weeks, is get my next year's students to some of them, try and get some of them to end up here in the next month or two, and maybe bring some of these. So we'll kind of play around.
Thanks for sharing your experiences. It sounds like you had a lot of fun.
Yeah. Well, no, and I need to talk to you anyway.
Oh, okay.
Right. I think we've got an outstanding email that we passed back and forth, so I need to chat with you. All right. Thank you.
Robots, are they available for people to buy or use? Is it open source?
Yeah, I'm going to put these together in my car. You know what? So they're open source because they all came off eBay. No, so you know what I did was I went and I had a hard time finding just this little frame, right? And now in hindsight I should have said, you know what, I'm just going to still go build my own in a better piece of plastic. But I bought the little frames, I bought the motor and wheel combinations, I 3D printed the little post and the battery holder and the motor mount that I have on here, and then I cut this piece of plastic out and pre-drilled a bunch of holes to hold the Arduino and a breadboard and stuff like that. So it's just really I just put it together. It was my budget. It was cheaper budget. I had to do it that way because I had a grant that was paying for this, so I didn't have unlimited funds to do it. So yeah, so they're really just put together.
By the way, what you're talking about is not a bug, it's a feature. You should leave it that way. All the robots are different, and it's a project for the class to discover the problems and ask them to resolve it.
No, absolutely. When I teach this in my semester-long classes, right? They're going to be trying to figure those things out. You know, I'm going to get them to a point where like, hey, it's doing this. What do I do? And I'm like, let's talk about the engineering behind that and why that's happening. So absolutely, we're going to make them solve those problems.